All right, here we go. Chemical bonding, naming covalent compounds. That last video, I totally crushed you with 18 minutes. Not really sorry, because it was only one page of practice, but I'm going to make it up to you in this one because naming covalent compounds is type easy, okay? Naming ionic compounds is a little confusing because you got to figure out if your transition metal needs a middle name, +2, +3, whatever it may be. Nomenclature for covalent compounds is like if you can count and you apply a prefix, which you do have to memorize, then you're good. Okay, so again, we're relating names of formulas together. So how is the name and the formula related for covalent molecules, which is a molecule that is sharing electrons between two nonmetals. So thing you got to know is the name of the first nonmetal always comes first, and the name of the second nonmetal ends in "ide." That seems awful familiar. Like ionic compounds always ended in "ide," so do covalents. All right, well, so what's the difference then? Well, the difference is that both nonmetals get a prefix telling of us how many of each is in the formula. The exception is mono on the first nonmetal. So like if there's only one carbon, you wouldn't say like monocarbon, monoxide. This is kind of redundant, okay? So that's the only exception. You don't put mono on the name of the first nonmetal if there's only one. It's just not necessary, okay? So here's your prefixes. 1 is mono, 2 is di, 3 is tri, 4, not quad, it's tetra, because it comes from Latin. Or no, it comes from Greek, not Latin. Quad is Latin, tetra is the Greek. Penta, Greek. Hexa, Greek. Hepta, Greek. Octa, Greek. Okay? So it's like counting. Mono, di, tri, tetra, penta, hexa, hepta, octa. You try it. All right? So these are not in your reference table, so you got to learn them. In my experience, to be honest, you got to memorize up through penta. Hexa, hepta, octa are a little bit more rare, but they do show up. So just memorize. It's not that big. All right, here's the deal. Turning a molecular compound name into a formula. So CO. We know how many carbons there are. We know how many oxygens there are. What the heck would its name be? Well, the first nonmetal says its name, carbon. The second nonmetal gets a prefix to tell us how many there are. Mono, or monoxide. Carbon monoxide. It's done. Next. No mono on the first metal, remember. Nonmetal, remember. So, again, CO2. We know how many carbons, we know how many oxygens there are. Carbon, no, not monocarbon. Di for 2, dioxide. Okay, because there's 2 oxygens, carbon dioxide, simple. No mono on the first nonmetal. This one is dihydrogen. Why? Because there's 2 hydrogens, so there's 2, it's dihydrogen, says its name. Monoxide, 2 hydrogens, 1 oxygen. That's the formula, relates to the name. Name relates to the formula. Back and forth, back and forth, back and forth. Formula is the name. The name is the formula. It's kind of the relationship. Diphosphorus, because there's 2 phosphorus atoms. Trioxide, because there's 3 oxygens. Cake. Honest to gosh, I wish ionic compounds were named in the same way because it's so much simpler. Why come we can't say sodium monochloride, right? I mean, it's NaCl. We got to say sodium chloride. You know, whatever. Let's go backwards. Got a name, got to get the formula. Carbon tetrachloride. Well, there's 1 carbon and 4 chlorines. Remember, the number in the subscript applies to the previous element. So when we say tetrachloride, it means there's 4 chlorines, but we put the 4 down and below the chlorine in the formula. That's all there is to it. Nitrogen trihydride. Well, nitrogen is an N. Hydride, hydrogen, H, tri. 3 of them. So I guess the hard part about some of these is this. Figuring out what the second element is. Okay, I underline those to keep that in mind. Okay, sulfur, that's simple, you find sulfur. Difluor, fluorine? Yes, fluorine. Two of them, SF2, done. Dinitrogen, so this means there's two nitrogens. Trioxide, what starts with oxygen? There it is. Try it, three of them. So remember, there's only really like 11 nonmetals to deal with: carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. Those are the ones we're going to use. I don't think I'm going to throw any bromines or iodines at you, but I mean, if I do, there's only a couple more. I mean, so the root of those words that I underlined in red is the indicator of what element we're talking about. So that might be the hardest part, to figure out what the second nonmetal element is, but there's only like 10 or 11, so your choices are limited. There is 2 pages, 18 and 19 on this. You'll need a periodic table to do these pages and a Google Classroom assignment to back it up. So keep in mind, Lewis structures of covalent compounds, difficult, rare. Naming covalent compounds, easy, common. Naming ionic compounds, easy, common. Drawing Lewis structures of ionic compounds, difficult, rare. So typically speaking, the things that I spent more time on, that 18-minute video, is kind of rare. That's why there's only 1 page of practice. So back it up, finish it up, turn in them assignments, keep it rolling. Thank you for watching.